Okay, we're going to find out if this sequence here not converges or diverges. I've been doing a bunch of diverges videos, but we're going to find out if it is bounded and if it's always increasing or always decreasing, or if it's not monotonic at all. So if it's not monotonic, it means that it switches. So it's not always increasing, it's not always decreasing. It sometimes increases, sometimes decreases. That's what it means to not be monotonic. If you're monotonic, you always increase, always decrease, or always increase or always decrease. So let's check first if it in fact is monotonic, if it is always decreasing or increasing. The way you do that is pretty simple. You could just take the derivative. You take the derivative of this by remembering, if you've been doing a lot of these sequences, you've been doing a lot of L'Hopital's rule, where you take the derivative of the numerator and derivative of the denominator. But that's not what you do here. You just take the derivative in a normal way you would do it, which is the derivative of the top function times the derivative of the bottom function minus the derivative of the bottom function times the derivative of the top function, all over the derivative of the bottom, all over the bottom function squared. So that's really what we have. The derivative of the top becomes -1. The bottom is 2 plus 1. So we got 2 plus n, Derivative of the bottom is 1 times whatever we have in top, which is 1 minus n. So we solve for this, we get -2 minus n minus 1 plus n. Everything cancels out, just leaving us with -3. We're left with -3 up here. And so we can already tell that yes, this is monotonic. We took the derivative, and the derivative is always going to be negative. It's being multiplied by a negative number there. So this is definitely monotonic, decreasing because it's negative. Monotonic, decreasing. So now we're going to try to find out if it's bounded. The way you find out if it's bounded is you take the limit as n approaches infinity of that sequence, 2 plus n. So what's going to happen if we plug in infinity? Well, the way to figure it out is by dividing by n. We have n here, we have n here. You get 1 over n minus n over n over 2 over n plus n over n. So we get -1 and we get 1. This goes to 0 because we're plugging in infinity. Limit as n approaches infinity, that's going to 0. So we're left with -1 is the limit of that sequence when you go to infinity. So it's what you would call its lower bound, because that's what happens when you go all the way out to infinity. Its upper bound is the very first term you put in. The very first term of a sequence is always 1. So if you plugged in 1 here, you get 1 minus 1, that's 0. 0 over anything is just 0. So the upper bound is 0. Upper bound is 0. And this is the lower bound. -1. But I don't think they really ask for that in your book. they're asking for what is it bounded, first of all, and is it monotonic? If it's monotonic, it's either decreasing or increasing.